Do you want to burn more fat, control blood sugar, and boost energy, all from one drink? Yerba mate is a traditional South American brew packed with bioactive compounds. Think caffeine, theobromine, polyphenols, and saponins. Clinical studies show yerba mate helps with fat loss, insulin sensitivity, and satiety without any harsh side effects. It even activates GLP-1 and supports your mitochondria. Mate increases fat burning during exercise, regulates glucose, and promotes browning in fat cells, helping your body waste calories as heat instead of storing them. You might be wondering which yerba mate I personally use and what makes it different. This is lecture 113 of the Metabolic Classroom. Looking to improve your own metabolic health? Visit insuliniq.com for courses, coaching, consultations, and a 10-day free community membership trial. To dive deep into the science behind metabolic health, become an insider at benbikman.com, where you'll enjoy my exclusive content, ad-free podcasts, live stream Q&A access, and more. Welcome to the Metabolic Classroom. Thanks for joining me for this mini lecture. I'm Ben Bikman, professor of cell biology and biomedical scientist. In today's mini lecture, we are exploring a topic that's close to both my research and personal interests, and that is yerba mate. This traditional South American brew is not just a pleasant alternative to coffee, it's a metabolic agent with meaningful effects on things that I care a lot about as a metabolic scientist, including fat metabolism, glycemic control, mitochondrial effects, and more. Now, by way of brief background, yerba mate is more than a drink. It is, in fact, a cultural staple in many countries throughout South America, like Argentina, Uruguay, and Brazil. It's traditionally shared in a gourd with a metal straw called a bombilla. Now, beyond the ritual, which I confess I find quite enchanting, after all, I'm a creature of habit, the science is what really interests me. So as we go through this mini lecture, I'll do a little bit more of a deeper overview of yerba mate, and then we're going to examine some of its key bioactive compounds, where the rubber meets the road, and then we'll explore what these compounds do in a metabolic context. So what are the metabolic effects? This is going to include some things like fat oxidation, enhancing some mitochondrial effects in some remarkably cool ways, as well as modulating satiety hormones. All right, so let's just start firstly with defining yerba mate. Yerba mate is the tea that comes from the leaves of a plant called Ilex paraguariensis. That's the plant. Ilex paraguariensis. So it actually is easier for me to say if I roll my R's. All right, and it's an evergreen tree that's native to the subtropical regions in South America, like the countries I just mentioned. And in this case, the leaves are dried. Sometimes they are dried over wood smoke to get more of a kind of smoky flavor. And then it's steeped in hot water that you actually use to make the brew or the tea itself. The flavor is often described as quite earthy and definitely has some bitter taste to it. And that's something we're going to talk about. In fact, it's one of the more fascinating aspects of it. But all of this does make it a little unique compared to other plant-based teas. Historically, the indigenous Guarani people used yerba mate for its stimulant and medicinal properties. And today it's consumed worldwide at this point for its energizing effects. And it really is kind of considered an alternative to coffee. Nutritionally, yerba mate provides several vitamins and minerals, things like B vitamins, vitamin C, potassium, magnesium, alongside a suite of bioactive compounds that we'll get to in just a moment. Now, from a metabolic standpoint, which is why a metabolic scientist like I am even talking about this, yerba mate has been associated with several metabolic benefits that we'll go over, like improved insulin sensitivity, weight management, even some cardiovascular benefits. Sometimes, as I will cite further down, I have to rely on some animal studies because we just don't have some human parallels to it where I would be able to take muscle biopsies and fat biopsies. We're able to get that more easily from animals. All right, well, I'm certainly not claiming that yerba mate is a cure-all. I think you're going to find that the health effects that we go through are pretty promising. All right, now, with regards to the health effects, let's explore some of the key bioactive compounds because there are several classes of compounds that contribute to and really are the mechanism of the benefits of yerba mate. These classes of compounds fall into the families of xanthines, polyphenols, and saponins. So first, xanthines. The most famous xanthine, which is a name you've never heard, is one, in fact, you have heard, which is caffeine. It is the primary stimulant. But there's another one because yerba mate often isn't considered a strong source of caffeine, certainly not as much as coffee is. But there's another xanthine called theobromine, and it promotes vasodilation and contributes to mood and energy stability. And it's also been shown to stimulate lipolysis, which is something we're going to talk about in a moment in more detail. Of course, that's the breakdown of fat for energy. Next, polyphenols are a big class of compounds, and this in yerba mate includes perhaps the most relevant one of all, in fact, perhaps the most relevant compound of all, chlorogenic acid. This compound acts as a potent antioxidant and has been shown to slow carbohydrate absorption, which is something we'll talk about in a minute, by specifically inhibiting certain enzymes involved in carbohydrate digestion. It also reduces oxidative stress and has some pretty interesting effects on mitochondrial function, all of which is stuff we're going to get into. The next class of compounds is saponins. If you ever drink yerba mate, you may find that it has quite a foaming effect, especially if you're blending it with a little frothing tool. It really will foam. Well, it's the saponins that contribute to that. The saponins also are one of the molecules among a handful that contribute to the bitter taste, which again has some remarkably cool specific physiological effects that we'll get to. It's also been shown to regulate lipids. And what I would find very compelling is the evidence that it lowers triglycerides accumulation, specifically in the liver. So that's something that suggests it can help with fatty liver disease, as well as some anti-inflammatory effects. Now, there are some other things, other ones you might recognize, like quercetin, that are also found, albeit at smaller levels, but all of that and some others would just further contribute to some of the antioxidant defense claims and evidence that we see with yerba mate. But of course, we have to consider the brew as in its entirety. These compounds don't work in isolation, that there is very likely some synergistic effects where you have a multifaceted impact on metabolism that not perhaps one single molecule can explain, although I'll attempt to tease that out where I can. But please appreciate the fact that these are all coming together. All right, now what about so what, we could say? So what if we have these compounds? What are they doing? So let's now transition into some of the effects, some of the so what. First of all, I thought as I describe some of the metabolic effects, I wanted to just start with the big one, which is just fat loss. Most people are going to be interested in, to some degree, in yerba mate because they are interested in losing weight. That's something most people worldwide are interested in. So let's start with fat loss. In a 12-week randomized double-blind placebo-controlled trial, that's checking all the boxes of scientific rigor, obese adults who consumed 3 grams of yerba mate extract daily lost an average of 1.5 kilograms of body fat compared to 0.3 kilograms in the placebo group. So that's a 5 times greater fat loss. Waist to hip ratio also improved dramatically, and there were no adverse health effects reported. So please appreciate that. That was a 12-week time period. The only thing they did was start drinking yerba mate. They were not encouraged to make any other differences, and they had 5 times greater fat loss than the placebo group. A separate study showed that overweight participants who took green mate extract, so kind of the younger version of it, for 6 weeks lost a half a kilogram of fat, while the placebo group gained 0.2 kilograms. So body fat percent improved, no surprisingly, in a similar direction. So more evidence. Now, the weight loss was modest, sure, but easy as well. That was the only difference, and it was very targeted. You'll note that in both of these studies, I'm specifically referring to fat loss, not just weight loss, which can include all kinds of things. So this does suggest that there is a specific effect with fat. And now let's talk about that. Let's talk about fat oxidation or fat burning directly, because there's evidence to show that yerba mate can specifically target that. One of the studies I have that you can gain access to for the insiders is a 2015 study where they explored the effect in 11 healthy women. They took 2 grams of yerba mate before some low intensity, or they considered it moderate actually. I think the VO2 max was about 40%. So some moderate intensity cycling. And they found that just by taking this yerba mate in the absence of any other stimulus, they increased fatty acid oxidation by 24% versus the placebo group. A similar study found that yerba mate significantly reduced the respiratory quotient, the RQ, which indicates a shift toward fat as the primary fuel. Now, let me just describe that briefly. If you've ever seen someone who has the device strapped across their face and they're on a treadmill or a bike and they're exercising, one of the outcomes, one of the measurements that clinical or scientific team is measuring is the respiratory quotient, which is an analysis of all the gases. Well, all the gases, primarily just 2. It's the oxygen they're consuming combined with what's coming out, the CO2 coming out. And based on that ratio of oxygen in and CO2 out, the scientific medical team can get an indication, they can use that as an indicator of which fuel source the individual is burning. Are they primarily glucose burning or are they primarily fat burning? So, to the point, with fat burning, they found that in this exercise study, respiratory quotient was significantly reduced, which does not mean it doesn't mean it's less than, it just means it's more in the fat burning spectrum. So if we were to, rather than call it an upper or a lower, a higher number means more glucose burning, a lower number means more fat burning, we could lay it on a spectrum in a horizontal format and say what happened with the yerba mate supplement before exercise is that it made the people burn more fat during exercise. That's a good thing because when you exercise, glucose is always in limited supply, whereas for all intents and purposes, we have a practically limitless supply of fat. So we can get a lot more out of our workout if we can be relying on fat. Now, mechanistically or bioenergetically and biochemically, these effects are likely due to activation of an enzyme within the cells of the body called AMPK. That's sometimes considered an energy sensor, that when AMPK is activated, it will promote fatty acid oxidation, and it will also promote mitochondrial biogenesis. So the fact that we see some pretty robust increases in fat burning with yerba mate supplementation prior to exercise, it's likely a result of yerba mate also being known to activate AMPK. Now, beyond fat burning, yerba mate can support blood glucose control. And this is largely known to be an effect through chlorogenic acid. And this is an important effect. Of course, certainly someone like me would say that, given all of my focus on glucose control and insulin signaling in the human body. In a human clinical trial, chlorogenic acid, when given 30 minutes before an oral glucose tolerance test, so let me just lay that out. They're about to take that 75 grams of glucose in the oral glucose tolerance test, where you drink that little syrupy solution and you have your blood drawn for the next 2 hours. 30 minutes before they did that, they took some oral chlorogenic acids, which is that main polyphenol in yerba mate that I described earlier. They found that in the early spike of the glucose, it brought down the glucose levels by 11%. Now, it was statistically significant, but we would say, oh, well, that's not overly potent. Where it gets a lot more potent and compelling to me is that the insulin curve was also measured in this study, and the insulin curve was brought down by about 40%. So almost half. It almost lowered the insulin curve by half by just taking in some chlorogenic acid, 40% reduction in insulin. So perhaps there's some use case for yerba mate when it comes to you timing its consumption with when you might be deliberately consuming your highest carb meal. It's a pretty compelling effect. All right, let's move on, because the next one is the one that you may find the most interesting. I find this very interesting because it allows me to touch on some unexpected quirks of human physiology, and this is how yerba mate influences satiety via bitter taste receptors. So there's some compelling evidence showing that yerba mate influences appetite in a favorable way. You drink yerba mate and hunger goes down. But it could be in part because of the activation of these bitter taste receptors. I remember when I first started consuming yerba mate, and I'll talk more about that in a few minutes, I remember hearing people kind of complain about the slightly bitter taste. And the irony is that might be one of the most potent mechanisms that explain in the body how yerba mate elicits such favorable metabolic benefits. So don't apologize for the bitter taste. This is something you'd want to lean into. Now, when you think about bitter taste receptors, you of course think about what you feel in your mouth, what you taste on your tongue. What you don't know is that you also have bitter taste receptors throughout your gut. So you have these, you can taste, I'm using air quotes there for those who aren't watching me, you can taste the bitter taste receptor. You can taste the bitterness of something even through your guts. Now, you're not sensing that bitter taste at that point. That's not how the guts are wired neurologically, but you still have those same receptors that are eliciting taste sensation in your tongue and in your mouth. When you drink this and it hits your tongue, you are sensing the bitter taste, but those same receptors are located further down beyond the stomach, or beyond the stomach, certainly beyond the mouth, through the small intestine. And these receptors are they're located on what's called enteroendocrine cells. So they're cells of the digestive system, which is the entero aspect of that term I just said, but then there's some hormones. So when these bitter taste receptors in your gut are activated, they actually will be stimulated to release certain famous satiety hormones like cholecystokinin, abbreviated as CCK, or another one called peptide YY, often abbreviated just as PYY, and then the most famous of all, GLP-1. So when bitter taste receptors are activated, you will get a GLP-1 response. And we'll, of course, talk more about GLP-1 in a moment. That is not a stone I can leave unturned in today's fervor for all things GLP-1. But suffice to say, these hormones signal satiety to the brain via both a nerve signal called the vagus nerve, and of course via the bloodstream. But collectively, there's a pretty powerful effect reducing appetite and slowing down the degree to which you're going to want to continue to eat. So it's going to just tap the brakes on your hunger. Clinical studies using other bitter compounds have really shown support for this mechanism, particularly with that CCK effect. When CCK is activated or increased, it really promotes a strong central satiety signal to the brain. Now, one other fascinating aspect for bitter taste receptors is that as much as we have them in the mouth, no surprise, in the gut, a little surprising, you also have them on your fat cells, which, come on, admit it, is the most surprising of all. Now, you're not surprised to learn that I want to focus on the fat cell. I am, after all, a fat cell-focused scientist. But you have bitter taste receptors, just to put a fine point on it, in your fat cells, especially your white adipocytes, the white fat. That is the fat that we can pinch and jiggle, that jiggles just beneath our skin. Now, the research on this is early, but there's some evidence to suggest that when bitter taste receptors on adipocytes are activated, they can influence lipolysis as well as adipokine signaling, so stimulating the fat cells to release favorable hormones like adiponectin. So all of this certainly suggests that yerba mate can have a very quirky and unexpected effect, not only on the bitter taste receptors in the mouth, but also in the gut and even potentially on the fat cells, which have the same bitter taste receptors. So the fat cells are enjoying the bitter taste, even sometimes if perhaps we might not. Although I love bitter taste, maybe typical old guy taste buds here. All right, now I'd mentioned GLP-1 a moment ago, and given the fervor and excitement on GLP-1, let's revisit that briefly. And to my great delight, I can cite data from my own lab. In my own lab, we investigated yerba mate's effects on the incretin hormone GLP-1. And just as a reminder, and sort of very, very quick primer, the incretins is the term to refer to the class of hormones that is hormones coming from the guts. And GLP-1 is the most famous at the moment. But it wasn't always the most famous. There are a lot of them. But GLP-1 is the most famous right now. So we published a report on this within 2025, just a few months ago. Now we used mice on this because it's hard to get adipose, it's hard to get gut biopsies from humans. So sometimes where you got to get a little more mechanistic, you need to go to an alternate to the humans, which in this case is rodents. So we found that yerba mate supplementation increased the GLP-1 production from the jejunum, that's the middle part of the small intestine. So it dramatically increased GLP-1 expression and GLP-1, so the gene within the jejunum itself, within the small intestine, and then the actual plasma levels of GLP-1. Now, interestingly, when we actually were growing little L cells, those are the cells from the small intestine that actually make GLP-1. When we were growing L cells and we incubated those L cells with a yerba mate suspension, there really wasn't any, there was a very modest effect on GLP-1. But when we took one of the metabolites, so this is particularly one called dihydroferrulic acid. So one of the polyphenols I didn't even mention in my list earlier that would kind of be a sibling to chlorogenic acid is a molecule called ferulic acid. It also has many of the same effects of chlorogenic acid, albeit perhaps a bit more modestly. So ferulic acid is a known component of yerba mate. And we found that the ferulic acid itself had a modest, but it was an effect on increasing GLP-1. But what's interesting about ferulic acid is that it doesn't stay as ferulic acid when you consume it. When ferulic acid interacts with gut bacteria, it is converted into a metabolite called, as I noted a moment ago, dihydroferrulic acid. And when we incubated the L cells, the GLP-1 producing cells of the small intestine with dihydroferrulic acid, then we saw a huge, almost threefold increase production of GLP-1. So this was a cool study. Not only, it was a little unexpected, but it really suggests that there is this yerba mate microbiome interaction that really helps elicit some of the main benefits of yerba mate consumption. All right, now before wrapping up on the mechanisms that explain how yerba mate can lead to some significant fat loss and overall metabolic benefits, and remember that 40% reduction in insulin secretion, thank you very much. Don't forget that. It's fascinating and I believe really relevant and powerful. I also just want to share one more study from my own lab, a 2023 study. As you can see, I've had quite an interest in yerba mate for some time. This was a really cool study. It was, again, just a few years ago, and we actually explored the effects of yerba mate supplementation across multiple tissues. So we looked at skeletal muscle, we looked at adipose tissue, so fat tissue, and liver. And what we found is that in skeletal muscle, yerba mate supplementation improved mitochondrial coupling. In other words, for every unit of oxygen being consumed, ATP was going up as well. So we would say that the mitochondria in the muscle were very efficient. So this, I often will use a metaphor of revving an engine, and then whether the engine's in park or in neutral. So when the engine is, in this case, in the muscle, we would say the engine, or not neutral, not park and neutral, whether the engine's in drive, like it's actually in gear to be moving in drive, or it's in park, we could say. So drive or park, that'd be the difference. And then the muscle, it's in drive. You are pressing the accelerator and you're seeing the engine revving. This would be like the mitochondria consuming oxygen. But now the question is, are we getting anything out of it? Which in the engine would be, are we moving the speed? Are we actually moving the car now? Are we seeing a change in our speed? And that would be efficient. And that's what we see in the muscle. We're consuming oxygen in the mitochondria and we're getting some work done. In contrast, when we looked at white adipose tissue, the yerba mate supplementation increased mitochondrial uncoupling. So it was increasing oxygen, but not a concomitant increase in ATP production. This is in the cell what's called a thermogenic effect. And so if we come back to the engine, and I'll revisit that term, thermogenic, but this is something I've talked about adequately in the past. You're revving the engine, so we see the RPMs going up, but we're in park. We're not actually moving the car, so we're not getting any work done from the engine, but we are getting heat. And that's where the thermogenic effect is coming from. So if you'd say, you hear the engine revving, but you'd say, well, that car's not moving. So what is the fuel that's being burned? What is it being used for if it's not getting work done, like it was in the muscle? In the case of the fat cell, it's simply generating heat. So you're wasting fuel. Now, of course, in our car, and given how expensive fuel is nowadays, that is not good. But considering that the average person has hundreds of thousands of calories, if not millions, stored as energy in their fat cells, Making your fat cells be a little less efficient and be wasting some of that energy as heat, that is a pretty favorable metabolic shift. Now, I noted before we finish here that we also looked at the liver. Why look at the liver? Because the liver is at the nexus of a lot of redox biology in the body. So when you talk about being able to handle antioxidant mechanisms, the liver really has to deal with a lot of it through glutathione and other related processes. What we found is that with yerba mate supplementation, a shift toward a more reduced redox state, suggesting some enhanced antioxidant defenses. So a favorable development in the liver as well. So through muscle with greater efficiency, through fat cells with greater inefficiency, albeit I would argue in a very favorable way to today's environment of calorie and fat cell excess, even through the liver with the shift toward a greater antioxidant capacity. That one particular paper we published in 2023 really has a lot to chew on, a lot of benefits that I think ought to be noted. Now, as a final note, you can tell, I think, from all of this that I'm a little enthusiastic about yerba mate, and I am unapologetically. So and speaking of unapologetically, my preferred source of yerba mate, just if you're curious, I know a lot of people, as they're getting interested, have their own, perhaps even their own brands, but also brands that they just prefer. My preferred brand is one from the company Unicity, and the name of it is Unimate. You can look it up. It's just Unimate, then the E, of course, with the little Aku sign on it. Now, full disclosure, I serve as a scientific advisor to the company, but by way of full disclosure, that relationship developed after I'd already been testing and using the product on my own. It's sort of what initially got me interested. Now, so I want you to know the disclosure, but why have I enjoyed it? In addition to just the taste, which I find to be vastly superior to any other version of yerba mate I've tried, I like its purity and potency. I like that it isn't using smoked yerba mate leaves, because the smoking process can actually increase the presence of contaminants. So be very mindful of if your yerba mate supplements coming from smoked leaves. These are not smoked. So they have a different process, hand harvested from a very high altitude, very, very selective farming sources, and an overall extraction process that I think enriches the chlorogenic acids more than any other source of yerba mate. So for those who are seeking some of the metabolic benefits of yerba mate and you want to get some of the confidence that you're getting it from a good source, then I strongly recommend you check out Unimate. It is the formulation certainly of choice for me. And if you're curious about it, again, I'm a scientific advisor, so I've already stated that. You can find a link in my show notes if you do want to give it a try. Of course, regardless of how you get it, if you are now curious because of everything I've described, and it'd be amazing if you weren't, I hope you'll share with me on social media some of what your experiences are if you do give it a try. As I've shared with you a couple of my own research articles from my lab, it's something that I've really become pretty interested in. Thanks for listening to this Metabolic Classroom. Until next time, more knowledge, better health. Looking to improve your own metabolic health? Visit InsulinIQ.com for courses, coaching, consultations, and a 10-day free community membership trial. To dive deep into the science behind metabolic health, become an insider at benbikman.com, where you'll enjoy my exclusive content, ad-free podcasts, live stream Q&A access, and more.